Right, this is question 4 of the diffraction questions. Again, remember you can go at your own pace through these and you may be able to arrive at the same answer in a slightly different manner. So if we look at this question here, we can see that we're looking at a lot of information here about a light-dependent resistor being moved across again, and we're getting to see the different fringes of the light as we move across. Other important things is laser beam, monochromatic light, wavelength 633 nanometers, that's going to be important, and we've got the distance of the diffraction grating as well. So let's see if we can solve this first question. Show that the angle of the first order image measured from the straight through position is approximately 3 degrees. So if I go to the next slide here that I've put together for you, what we need to be thinking about is that we're coming from here, from this point here, and we're looking to measure the distance to these first order fringes. Okay, so that's the angle that we've got going on at that point there. Okay, so what we want to do is that's going to be equal to 2 lots of that angular difference, because what we're looking at here is we're looking at basically 2 right angle triangles. Okay, and we've got our theta there. So this distance here is going to be 2y. So the distance between here and here is going to be y. All right. Now, if we look, and we've got the diffraction, the distance from the diffraction grating, and if we look at these two values here, I've got that out as about 5 there and 32 at the point where these maxima are occurring. We can work out that 2y is 27 and y is about 13.5 millimeters based on the my interpretation of the graph. So we've got our distance to the grating of 265 millimeters. We're going to use this equation again, sine theta equals y over d. We're going to rearrange that to get theta, and in doing so we're going to put our values in there in meters, and then we should get an angle of approximately 3 degrees, which is what you've been asked to work out. Question A, part 2, coming up hopefully. Alright, calculate the number of lines per millimetre on the diffraction grating. So what we've got here is we're going to use the diffraction grating equation again. Okay, so for the first order, which is what we're looking at, so n is equal to 1, we've got the wavelength of light as 633 nanometers, and we've got our angle of 3 degrees that we've just derived. So using that information, we can put that into our equation, our rearranged equation, and we can see that d is equal to 1.23 times 10 to the 5 meters. Final thing that we need to do is that is the number of lines per meter. So if we divide 1 meter by the number of lines that we've got, we'll get 8.13 times 10 to the 4 lines per meter. Okay, and that answer we're going to divide by 1,000 in order to get 81.3 blah 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 81 lines per millimeter. So that's the answer that we're looking for there. 3 steps that you need to do for that.